All right, let's get right into it. We're going to go beyond the hype and talk about what's really going on with an AI's memory. The actual engineering of it all, how it works, and maybe more importantly, why it so often breaks.
So have you ever had this happen? You're deep into a really complex chat with an AI, you think you're making progress, and then, poof, it completely forgets a critical piece of information you gave it just 10 messages ago. It's super frustrating, right? Well, there's a reason for that, and we're going to look at what's happening under the hood.
And the culprit has a name. It's called the context window. Seriously, this one thing is the single biggest bottleneck, the biggest constraint on what an AI can actually remember. And if you want to understand how we get to smarter, more reliable AI, you have to understand this concept.
Okay, so the problem with this context window really boils down to three big issues. First off, it's expensive. You get billed for every little piece of information, every token. Second, it's small. It's got a hard limit on its size. And third, and this is the really sneaky part, its performance starts to degrade long before it's even full. They call this context rot, and it's a huge deal.
So let's really dig into this memory problem. I mean, how can this incredibly powerful technology struggle with something so basic, like just remembering what you talked about at the start of a conversation? What's the deal?
The easiest way to wrap your head around the context window is to think of it like a workbench. It's the AI's short-term memory. It's where it lays out all its tools and materials for the job at hand, your prompts, its own previous answers, any files you've uploaded. But just like a real workbench, it's not infinite. It gets cluttered and things can get lost.
And this is where things get really different from us. Our brains, they're amazing. Our memory is huge, it's associative. We just connect dots without even trying. And AI's context window, it's the complete opposite. It's tiny, it's literal, and it's super expensive to use. See, it doesn't understand the history of your conversation. Every single time it replies, it has to reread the entire script from the very beginning. Imagine having to do that. That's why it costs so much.
You see all this marketing, right? Models bragging about these massive context windows, 200,000 tokens. But here's the dirty secret. You never, ever want to actually fill it up. As you start cramming more and more stuff in there, the AI just gets confused. Performance tanks, and it starts making weird mistakes. That's context rot in action. It's just like that messy workbench. You've got so many papers piled up, you can't find the one thing you actually need.
So, what's the fix? Well, smart engineers aren't just sitting around waiting for bigger context windows to come along. Nope, they have a strategy, a real master plan for managing this limited memory. It's a framework called WSCI.
Okay, WSCI. It stands for Write, Select, Compress, and Isolate. Think of it like this. Write is like taking a really important note and filing it away for later. Select is about going to that file cabinet and pulling out only the one fact you need for the job right now. Compress is basically cleaning up your workbench by summarizing your messy notes. And Isolate? That's like setting up a whole new, perfectly clean workbench just to focus on one specific part of the job.
All right, of all of those, I want to focus on what is probably the most powerful technique right now. It handles the select part of our plan. It's called Retrieval Augmented Generation, or RAG for short. And honestly, the best analogy for it is just brilliant. It's like giving the AI an open book exam.
So instead of trying to cram the entire textbook into its tiny short-term memory, the context window, RAG lets the AI have a library right next to it. It can look up information in that external library, find the exact right page or paragraph, and then use that specific piece of information to answer your question. It's all about selecting what it needs precisely when it needs it. So much smarter, right?
So how does this open book exam actually work? Well, it's a pretty cool pipeline. First, you take your whole library of documents, and you chop it up into smaller, digestible chunks. Step 2, you convert each of those chunks into a special number code. It's called a vector, and you store them all. Then you ask a question. This is where the magic happens. The system instantly finds the stored chunks that are the most mathematically similar to your question. And finally, the really important part, the LLM gets your original question plus those super relevant chunks you just found. With all that, it can give you a much more accurate, fact-based answer.
And this quote really nails it. The key idea is that the prompt the AI sees isn't just your question anymore. It's been augmented. It's your question plus a perfectly relevant retrieved document. This is how you give the AI access to a gigantic amount of knowledge while keeping its little workbench, its context window, nice and clean.
Now, RAG is definitely the star of the show, but it doesn't work alone. It's got a great supporting cast.
So let's quickly look at the last two pieces of that WSCII framework: compress and isolate. These are the techniques that are all about keeping that workbench tidy.
Compression is, well, it's pretty much exactly what it sounds like. Let's say your conversation is getting long, and your context window is like 80% full. You're heading for danger. Well, you can actually use the AI on itself to read the entire conversation and just create a short summary. Boom. Suddenly your context is down to maybe 10%. You've just freed up a ton of space. You've slashed your costs, and you've pushed back that nasty context rot, all without losing the important stuff.
So, to recap these two tidying tricks, you've got compression, which is like summarizing all your notes before a big meeting. And then you have isolate, which is great. It's like hiring a specialist. If the AI has to do something really specific, you can just spin up a brand new, temporary sub-agent with a completely clean context window. That way, the main conversation doesn't mess up the task, and the task doesn't clutter up the main chat. It's just clean.
Okay, let's tie this all together. Because these aren't just, clever programming hacks. These are the fundamental engineering principles that make the difference between a fun little chatbot you play with and a genuinely powerful, reliable AI tool that you can depend on. So, what are the big takeaways here? First, that context window is a limited, expensive resource. You have to treat it carefully. Second, the WSCI framework, write, select, compress, isolate. That's your game plan for managing it. Third, RAG is your #1 tool for giving the AI a massive external brain without clogging its short-term memory. And when you put it all together, well, that's how you do smart context engineering. That's how you turn a generic LLM into a high-performance, specialized machine.
And that really leaves us with a final, pretty big thought. For so long, the race has been all about building bigger and bigger AI models. But what if that's not the whole story? Maybe the next huge leap in AI isn't about bigger models at all, but about engineering a perfect memory. I mean, just think about it. If an AI could remember everything flawlessly and instantly, what new problems could we finally solve?